We're going to continue working on our HexNut part, so let's go ahead and recap where we're at. Select our OSE Fastener Workbench and click our button to add our HexNut. So this is all great, but what if we wanted to change the size of the hole or the height of the HexNut, maybe the distance between the flat to flat side? If we go back to our example workbench that we've been working up to, we can see that this HexNut part allows the user to change the height or the diameter of the hole and even the width across the flats, all from the property editor within FreeCAD, which gives the user much more flexibility into controlling the geometry of the part. So how would we do that? How would we accomplish that in code? And in order to do this, we're going to need two new concepts. So if we go to the OSE Workbench platform documentation, we have been talking about part classes, which we're now well familiar with. We have a HexNut class with a make method for making our HexNut part geometry. The new concepts that we're going to need to make this geometry dynamic are model classes. So we will create a model class for our HexNut. They kind of act as extensions to part classes for whenever we want this dynamic geometry that the user can control within the property editor. So there's more information, and I'll include links to the OSE Workbench platform documentation within the video description below. The other thing that we're going to need is something called a part feature creation function. So there is more discussion about that if you go to the Workbench package page. Scroll down a little bit. See a section that talks about part feature subpackage. So it's going to look something like this, and you can see it uses model classes, and so we're going to have to pull that in. We'll talk more about it. So let's go ahead and hop over to the terminal and see if we can make this happen. Close out of FreeCAD. We're going to need to be in the OSE Fastener Conda environment, and within the OSE Fastener Workbench repository if we're not already in there. And let's use the OSEWB CLI, do -h, and the command we're going to use is the make command. You'll also have been noticing that on some of these commands they have little parentheses and characters. These are short aliases that you can use in substitution of the full word. So let's go ahead and do that. So we'll type OSEWB make or mk -h for help. And what we're going to do first is create a model class for HexNut. So we'll say OSEWB make model and then -help. So we can see that this takes a name as a required positional argument, and the name is going to be the name of the model class in Pascal or upper camel case, something like my box. And so for our case it's going to be HexNut. So let's do OSEWB make model HexNut. Hit enter. So let's go ahead and go to Visual Studio Code and look what that did. So within the library package, the OSE Fastener directory, we now have a new top level package similar to part but for model, and it's structured much the same way. So there is a private package for the HexNut. It's private because it's denoted with a leading underscore, but it's exposed in this init.py file here. So if we go to our HexNut model class that was just created, we can see it's mainly just a little bit of boilerplate code, and want to bring our attention to this import statement. So we're importing a model class, but we're importing it from OSE Core, and this is a library that we created and we haven't talked about yet. So let's take a quick detour and do that. If we go back to the OSE Workbench platform docs and scroll down to this OSE Workbench ecosystem section, there's a page that discusses this, and the Workbench Core is a library that you're going to be using quite a lot. It's supposed to make life easier, and here's its respective documentation website. It just contains anything that would be common to all workbenches. It's supposed to abstract out that functionality. So if we go to the OSE Core app package, we can see there's more additional information on this base model class here, and that's what we're pulling in and extending from. So we also see that this execute method, this is kind of where the meat and potatoes of the model class is, and we need to replace this part.make box call with a call to make our HexNut. So let's import our HexNut part class. So we'll say from OSE fastener.part import HexNut. Replace part.make box with HexNut.make, and we can get rid of the 10 by 10 by 10. And that's all I want to do in our model class. The next thing we need is a part feature creation function, which is this guy here, as we see in the make command help. So let's go and do make, and we can shorten this PF for part feature, PF-H for help. So this is going to be the name of the part feature creation function in all lower or snake case, so it's going to be hex_nut, all lowercase. So OCWB make part feature hex nut. Okay, let's take a look at what that did. So we go to the Workbench package, which is the FreeCAD directory. There's now a new top or sub package called part feature. Similarly to the other packages, there's a private HexNut package inside of it, and an init file where we're exposing this new function that'll create our HexNut for us. We can see that this is importing our new HexNutModel class, and this function takes the a document and a name for the object we're creating. It's going to add a part feature object to the document and pass this object into the model class. I don't want to really talk about this right now, but it's necessary. And then it's going to return this newly created object. So we're going to need to use this new create HexNut function and call it with the document and name. And the place that we're going to do that is within the add HexNut command, within the command package. So here we're still using our part class, but now we're going to use our part feature creation function. And remember, the part feature creation function, this create HexNut function, is going to use our model class for us and then do a little bit of additional work. So it's a kind of just a nice way to abstract the object creation logic away from us. So let's first import it here. So we'll say from FreeCAD OSE fastener.part feature import create HexNut, and we can replace these two lines of code where we're making the hexagonal nut part and showing it. We can replace that with create HexNut. The first argument is the document, which we have here, and then the name we'll just say like HexNut, and it returns the object, but we're not going to do anything with it, so we don't need to set that to a variable or anything. Let's go ahead and give this a try. select our OSE Fastener Workbench and click it, and sure enough we don't see that anything happened, but we notice a little blue checkmark icon, and what that is a indication of is that we need to recompute our document because there's some additional work that FreeCAD can do. So we can do Control R or hit this little refresh button at the top, and then we see our part. So what's going on here is that creating this geometry is potentially expensive, especially when we're changing the some of the parameters at runtime and like recalculating and redrawing this. So what FreeCAD does is it makes you explicitly tell it whenever to redraw or recompute the document. Since we pretty much want to recompute the document right after we create the HexNut, instead of making the user have to hit the refresh button here, we're going to do that for them. And the way we can do that is say document.recompute. We'll try this one more time. Select OSE Fastener, hit it, and so now we can see that it created the HexNut for us and it automatically recomputed the document. So there we have it. I know it was a lot. I'm going to refer you to the documentation where we talk more about the part feature creation function. There's links to the FreeCAD wiki for additional information on what this stuff is. And in the next one, we're going to take one more step to actually add those properties so we can start changing some of these parameters after it's been created. Thank you for watching, and I'll see you in the next